Hi everyone, I'm gonna be doing question I'm gonna be doing question 4 of week 7B homework. Today we're looking at a problem about radioactive isotopes and also activity. And so the question is asking us two samples contain different radioactive isotopes. So is it possible for these samples to have the same activity? So So to set this up, I'm drawing two samples, as you could see here in the two boxes. So I have sample one and then I have sample two. So sample one has a certain number of radioactive atoms as depicted in the red dots. And then also sample two has a different number. So we want to figure out if their overall activity, basically like how fast they're decaying, can end up being equal. But before we get into the math, I'm gonna list all of our variables. So first we have A, and A stands for the activity. So activity just measures how fast a radioactive sample is decaying or how many decays happen per second. And so the SI unit for activity is in becquerel, which is depicted as a capital BQ. And that is which is just decays per second. And then next we have N. N is the number of nuclei. So this is simply like the count of radioactive atom cores in our sample. And so um since it's just a count, it doesn't also have SI units, so it's dimensionless. So none. And then we have lambda, which is the decay constant. And so this is the probability that a given nucleus will decay per second of time. And its SI unit is inverse seconds or S, the power of negative. And then finally we have T2, which is just the half-life. And so half-life is the time it takes for half of the sample's radioactive nuclei to decay away. And so the SI unit for this one is in seconds. So now we can look at the equation. So the main formula for the activity of a radioactive sample is A is equal to lambda times N. And so this just means that the activity depends on both the decay constant and how many nuclei you start with. But we also know that the decay constant, which is lambda, is inversely related to half-life by this equation. So that would be lambda is equal to ln 2 over t a half. And so if we plug back into our activity formula, we will get A is equal to ln 2 times n over t 1/2. And so if we just want sample 1 and sample 2 to have the exact same activity, we'll just set A1 is equal to A2. So that will be ln 2 times n1 over t a half 1 is equal to ln 2 times n2 over t and a half 2. And so notice that in both and ln 2 cancels each other on both sides. So then that will just leave us with n1 n1 over t and a half 1 is equal to n2 over t and a half 2. And so this just means that as long as the ratio of number of nuclei to life is equal for both samples, that means that their activities will be identical. So to answer the question that if even if two isotopes are completely different, they can have the same activity if they just have different numbers of nuclei and different numbers of half-lives. And so because those two differences can balance each other out in the fraction, that means that the answer matches our second option, which is yes, if they have different numbers of nuclei and different half-lives. And that's it. Thank you.